Hi, back to 8.3, one more problem, and then I just wanted you to see continuous. I think why there's some maybe misunderstanding on this one is because when you look at a continuous and we define it the way we just did for discrete, if you think that's the probability x is x and y equals y over probability x equals x, then um, it looks impossible because remember we said there's no probability at a point. So this is really 0 over 0 and it really doesn't make any sense. But we would still like to be able to find a conditional density function for y given x. So basically what this is saying through here, I'm kind of doing a little derivation, is that you have to think of it as limits, as x, the limit as x approaches this little x, right? So I'm really not saying x is exactly x, but as you approach little x. So this is kind of what I'm saying. I'm kind of looking for the CDF first, and then taking a derivative, and yeah. So wow, I'm not being very clear. So this won't be the nicest thing I say. Okay, so basically, the problem again is you don't really have equality. Think of these as limits as you approach x, as you approach y. You can't really think of exactly x equals x. It's just not going to be possible. So that's why I start deriving this, which is the CDF, and then I can take derivatives. But think of it as approaching x, and I just use a lot of ideas that you've already learned in calculus to get to the point that I wanted to. So big point, conditional, we're still dividing them exactly as we did before. It's the joint divided by the marginal, and again the joint divided by the marginal. So I notice I also put these on the quiz, so I don't totally want to do them, but I want to show you a little bit. You already know how to find. So I'll skip this. By now, I think if you're very careful and you draw your region of interest, that you can find the marginal of x. I mean, we've done that. Well, because it's continuous, we're going to integrate over a y. You should get a function for x. And then define the conditional here. The conditional really then is you're going to look at the joint over the marginal. So I didn't put everything here. This is the simplified version. So again, remember that this right here is equal to, let me go back to my pen. This is f of x, y over f of x. So in part A, you're finding f of x, and then you have this because you're given. So if you look at this ratio then and simplify it, this right here should turn out to be what you get for your conditional density function. So I'd like to see you show this. I mean, I'm giving you the answer to kind of make sure you did part A right and that you look at this division right, but this is what you should get down to. So assuming that I have that, I wanted to show you what I mean by this. So this is really the probability. Well, I guess I don't need to rewrite that. You already see probability. Okay, so let's get rid of that. So what is, it would be nice to have, let's go back to pen, f of, cancel that. Well, we already have f of y given x. So we want to look at now at f of y given x. Y given x is equal to 1. So I'm setting my x, and I'm trying to find the conditional of y, that y is between 2 and 3, given I've set down now x is 1. And again, not exactly x is 1 as x approaches 1. So if we go up to this function, this would be 6 minus 1 minus y over 6 minus 2 times 1. And now this is for y is between 2 and 4, because once we've set x, and y is not conditioned in the support on x. We've set x equals 1. X can be anything between 0 and 2. So when I set equals 1, if you want to even, of course I didn't draw the graph here, but imagine over this region of support, 0 to 2 to 2 to 4, I've set down now x is equal to 1, and y's range from 2 to 4. What's the probability y's between whatever I had in that question? I mean, here to here. So we're setting our y, or sorry, we're setting our x. So this is just the function 5 minus y over 4, right, for 2 less than y less than 4. And for every x you put in, this is a valid, I mean, you can check this is a valid density function. That's what we were showing on the other page. I was showing you conditionals when I said we can show with a little proof that they're valid. They always are valid. So now what's the probability y is between 2 and 3? So now I'm just going to use this function. So probability 2 less than y less than 3 given x is equal to 1 is just the integral from 2 to 3 of 5 minus y over 4 dy. And I'll get a value. So that's equal to something. And then actually down here, expected value of y given x is equal to 1. Again, we already know that when x is equal to 1, this is my density function. So this is just going to be the integral of f of y given x times y and dy, and y's go from 2 to 4. So it even gets more interesting when you have x and y dependent on each other. I guess I don't have that even in this problem, so it's not that bad yet. So I'm going to leave 5 then, because that's on the quiz too, and just let me know if there's anything you'd like to see more of.